y'all, welcome to Miss Clark's chemistry class. This lesson, we're going to talk about how to balance these. How to balance an acidic solution and a basic solution. We're just used to balancing normal reactions, and it doesn't matter what kind of solution they're in. But for a redox reaction, it does matter. We're going to have to go through just a couple more steps than what we're used to. So go get your notes, go get something to write with, and let's get started. Okay, so now let's talk about how to balance in an acidic solution. A lot of times these redox reactions are happening in solution, and oftentimes those solutions are going to be acidic. The rules don't really change. There's just a little bit of addition to the rules. Okay, so it's going to start out the same. Let's break this into its half reaction. Let's assign oxidation numbers first. We've got a +2. Let me change colors of pen. Nickel is a +2. Oxygen is a -2. So let's figure out chromium. You go ahead and figure out chromium. Let's make sure you get it right. Did you get a +6? Okay, this chromium is already a +3, nickel +4. We really only had one thing to figure out. Okay, so let's look and see what's happening here. Nickel is going from a +2 to a +4. Something's happening there. Chromium, we're going from a +6 to a +3. Yes. Oxygen, oop, there's not another oxygen. We're going to pick that up in just a second. That's going to be one of those new things that happening when you balance in an acidic solution. Okay, so let's break this in half. Nickel is going from a +2 to a +4. So if we're looking at nickel's half reaction, if we're going from a +2 to a +4, it's getting more positive. That means it's losing electrons. So it's lost 2 electrons. And if we look at chromium went from a +6 to a +3, meaning it's gained 3 electrons. Okay, so let's go back to nickel. We know that it lost 2 electrons, so we're going to show lost 2 electrons. Okay, let's do our other half. You know what? I'm going to change colors for the other half. We've got chromium, Cr2O7, dichromate. I apologize. And we've got the ion for chromium. And we gained 3 electrons. So let's write that. Remember, half reaction, balance by amount. So if we're looking at nickel, 1-to-1, no amount to worry about. Let's look here though. We've got Cr2, Cr. We do have to fix that. So I'm going to put a 2 in front of this chromium. Now let's go back and think. For every 1 chromium ion we made, we gained 3 electrons. But now we have 2 chromium ions. That's right. We've got to go and adjust that electron number. That is not going to be 3. It is going to be 3 times 2, which is 6 electrons. Don't forget to make that little change. Oxygens. You might be thinking, Ms. Clark, we do see those oxygens over there. Do you not see those? O7. When you're balancing in an acidic solution and you need to balance oxygens, we're going to add water. Because remember, water is the main component of an acidic solution. So there is going to be water available because this reaction is happening in that solution. So we need 7 oxygens, so we're going to put 7 waters. 7 oxygens, 7 oxygens. I know, I just created a hydrogen problem, but again, acidic solution. What is the other component of an acidic solution? That's right, hydrogen ions. So I am going to go back over to this side and I'm going to add 7 times 2. I am going to add 14 hydrogen ions. Okay, so the amount should equal 14 H's, 14 H's, 7 O's, 7 O's, 2 Cr's, 2 Cr's. I know that was kind of weird. When you're balancing in an acidic solution, you can add waters and hydrogens to help balance out any oxygens. Now let's balance for charge. We have 6 electrons here. We have 2 electrons here. So we need to multiply by 3. When we multiply by 3, that's going to give us 3 nickels. And that's going to give us 6 electrons. Those 6 electrons are going to cancel with these 6 electrons. Let's put everything back together. I know I skipped a step right there because it was getting a little cluttery. So I've got 14 H pluses. I've got 3 nickel. Again, you can add this in a different order than what I'm adding it. We have 1 dichromate ion. We've got 3 nickel +4s. Plus we've got 2 chromium ion +3s. Plus we have 7 H2O. That is a long answer, but it wasn't very hard to get. It just took a little bit of work to get it. Here's our answer. Let's remember what we did. We had 7 oxygens here, and we had no oxygens on the other side, so we added 7 waters. When we added 7 waters, that also gave us 14 hydrogens that we had to add on the other side, and you can do that because this is happening in an acidic solution. Okay, so we just looked how to balance in an acidic solution. Now we're going to look to see how to balance in a basic solution. The one good thing about this is it's exactly like acidic solution until the very, very end. So there's really nothing new to learn. So that's why I've got here, start by balancing in an acidic solution. So let's do that first. So I'm going to have Ag. So if I break in my half reactions, if I've got silver went from a 0 to a +1, so we lost an electron, so +1 electron. Nitrate, let's see what nitrate is here. Oxygen is a -2. We've got 3 of them, that's a -6, but we've got a minus charge right there, so we've got to end up with a -1. So nitrogen must be +5. Over here, oxygen's a -2. There's only one nitrogen, so oxygen has to be a +2. So nitrogen went from a +5 to a +2. That means it gained 3 electrons. Okay, so we have our half reactions. Now let's balance for amount. 1 silver, no amount to change there. Nitrogen, 1 nitrogen, we're good. 3 oxygens, 1 oxygen. Well, I can't put a 3 there because then that's going to mess up my nitrogens. So I'm struggling balance oxygen. Remember, this is in a solution. Water is the main component of a solution. So we need 3 oxygens. So I am going to add 2 waters. Now I have a total of 1, 2, 3 oxygens. But yes, I messed up my hydrogens. So I'm going to go and add 4 hydrogens. Hydrogen ions. Now we've got the bottom part balanced for amount. Let's do for charge. We've got 1 electron here. We've got 3 electrons here. So we're going to have to multiply our top reaction by 3. That's going to give us 3 silvers. That's going to give us 3 electrons. Those 3 electrons are going to cancel. Let's put everything back together again. So we're going to have 4 hydrogens plus 3 silvers plus a nitrate ion, arrow, 3 silver ions plus nitrogen monoxide plus 2 waters. Now, if we were balancing in an acidic solution, we would be done, but we're balancing it in a basic solution. Okay, so let's just take that equation that we had. Remember, we just balanced it in an acidic solution. Now we're going to add the step that's necessary to make this be balanced in a basic solution. So you're going to go and find your leftover hydrogen ions. It could be on either side. Right here, it's on our reactant side. That's how many hydroxide ions we're going to add, because remember, hydrogen, that means acidic. OH, hydroxide, that means basic. So since we have 4 hydrogen ions, we're going to add 4 hydroxide ions to both sides. Remember, what you do to one side, you got to do to both sides. Now, when you add 4 H's and 4 OH's, remember water, H2O, that's just HOH. So 4 H's and 4 OH's, that's going to combine to make 4 waters. Let's go ahead. I'm going to go ahead and rewrite the rest of this so it's all together. Okay, so I've rewritten this entire equation, but I'm wanting you to notice something. I'm wanting you to notice that I have 4 waters on this side and I have 2 waters on this side. We need to simplify. So if I've got 2 on my products and 4 on my reactants, we can just reduce that down. So if my final answer, I would have 2 waters, 3 silvers, 1 nitrate, and there is our final answer. Balance everything like it's an acid, add however many hydroxides you need to the hydrogens, turn those into water, reduce down if necessary, final answer. I have one that I want you to practice doing in an acidic solution. Pause the video, balance this out in an acidic solution, then come meet me back and make sure you did everything okay. Copper is a free element, so it's getting a 0. Oxygen, that's where I'll always start, -2. That gives us a -6, but the whole thing is a -1. That means nitrogen has to be a +5. Copper is a +2, it already tells us. I go over here to this. Oxygen's a -2. That gives us a -4. This is neutral, so in this instance, nitrogen has to be a +4. Okay, so our copper went from a 0 to a +2. That means it lost 2 electrons. Our nitrogen went from a +5 to a +4, means it gained 1 electron. Oxygen is not being reduced or oxidized, so we're going to ignore it. Okay, let's get our half reactions in order. Okay, here's our oxidized half reaction. Copper lost 2 electrons. I didn't want to forget adding my electrons. Let's balance by amount. 1 copper, 1 copper, 1 copper. We're good there. 1 nitrogen, 1 nitrogen. Oh, and our oxygens. 3 oxygens, 2 oxygens. Now remember, this is a case where we don't want to change our nitrogens because we would just be in an endless cycle. So we need 1 more oxygen. So I'm going to add a water. But when I added a water, that made me add. Okay, so I've got that balanced by amount. Let's balance it for charge. I've got 2 electrons here. I only have 1 electron here. So we're going to have to multiply this whole thing by 2. I'm going to go ahead and rewrite that out. So we have 4 hydrogens, 2 electrons, 2 nitrates, 2 nitrogen dioxides, and 2 waters. Our electrons are going to cancel. And then I'm going to add all of this back together. So 4 hydrogens plus 2 NO3 minuses plus a copper, NO2 plus a copper plus 2 H2O. Balancing in an acidic solution. Hope that went well for you. Okay, so for this last example, let's balance in a basic solution again. And just like we did with that acidic solution problem, I want you to press pause and get as far into this problem as you can. Hopefully you make it to the very end. So the first step that I always take is labeling the oxidation numbers. So if I'm having to choose between carbon and nitrogen, nitrogen is the more electronegative. It's the one closer to fluorine. And so it's probably going to stay true to its trend that since it's in group 15, it's going to have a -3 charge. So that's where I'm going to start, -3. Now we see that overall, this has to equal a -1. And I have a -3. So carbon has to be a +2 in this situation. And then we move over. When oxygen's there, that's where I always start. I've got -2 for oxygen. I've got 4 of those. That's like a -8. And again, we see this polyatomic ion has to end in a -1 charge. So what must manganese be for the overall charge to remain -1? Manganese has to be +7. So let's go over across the arrow. Again, I always start with oxygen, -2. And we see that this has got to be a -1 overall. Again, if we're looking at C and N, nitrogen is the more electronegative, so it's going to be negative. I'm going to go ahead and keep that -3. Okay, so I have -5, and I need to be at a -1. So carbon is going to be +4. And then my last compound, manganese oxide, -2. I've got 2 of those. It's like a -4. So manganese has to be a +4. Okay, so next let's take notes on what has happened. So let's go through this real quickly. Carbon went from a +2 to a +4. Nitrogen, -3, -3. Not really involved. Manganese, +7, +4. Oxygen, -2, -2. So we are looking at carbon and manganese. Let's start with carbon. So carbon went from a +2 to a +4. We're getting more positive. More positive means we're losing negative electrons. So we lost 2 electrons. Carbon did. Now let's look at manganese. Started at a +7, went to a +4. That's a difference of 3 electrons. And since our number is getting more negative, if we go from a +7 to a +4, we're moving in the negative direction. Electrons are negative, so that means we're gaining 3 electrons. Let's break this into its half reactions. So I've got Cn minus and CnO negative. And we're losing 2 electrons, so losing is on the product side. They're left over, they lost them. Let's do the other half reaction. And remember, gain needs to be on the reactant side. Okay, so we had this broken up into our half reactions. Now it's time to balance for amount. So I'm going to go back up to carbon. I've got 1 carbon, 1 carbon, 1 nitrogen, 1 nitrogen, but yes, there's that oxygen. So remember, we need to add water to fix that. I only need 1 oxygen, so I only need 1 molecule of water. But when I did add that molecule of water, I added 2 hydrogens into the situation. But that's okay, we can fix that. Now remember, the only reason why we can do this is because we're balancing in a solution. Okay, I think, oh no, we needed 2 of them, 2 hydrogens. 2 hydrogens, 2 hydrogens, 1 oxygen, 1 oxygen, 1 nitrogen, 1 nitrogen, carbon, carbon, we're good. Okay, let's balance the second one for amount. 1 manganese, 1 manganese. 4 oxygen, 2 oxygens. So we're going to need 2 more oxygens over here on the product side. So 2 oxygens means we're going to need 2 waters. And we see we've got 4 hydrogens, so we can go and add those 4 hydrogen ions to the reactant side. Everything should be balanced, but let's check. 4 hydrogens, 2 plus 2, 4 oxygens, 1 manganese, 1 manganese. Okay, so now it's time to balance for charge. We have 2 electrons and 3 electrons. By now, we're definitely used to seeing 2s and 3s and thinking immediately of 6. So we would need to multiply the top portion by 3 and the bottom portion by 2. I'm going to scoot all my stuff up first. This problem's getting a little bit cluttered, so I'm going to rewrite everything every time so I don't mess up. Okay, so if I go back up to the top, I've got. Now I'm going to multiply everything on the bottom by 2. Those are both long. How am I going to get those all in the same line? I'm going to have to write much, much smaller. Normally I would put this all back together and then start subtracting things out that are in common on the reactant side and the product side. But since this is so long, and we can see, here's our arrows right here in the middle. Let's notice that we have got 3 waters here and 4 waters here. We have 3 waters on the reactant side. We have 4 waters on the product side. So if we were to bring those 3 waters over to combined with the product, because you've got to take the smallest amount and give it to the biggest amount. Because when we cross this arrow, it's going to act like an equal sign. So when we cross that arrow, we're going to have to change the sign. So basically, we are going to do 3, and we're going to take that away from 4. So we are not going to have these 3 waters any longer. And we're not going to have 4 waters. We're going to have just 1 water. The other thing that we have in common, we've not canceled out these electrons yet, so let's do that, get those out of the way. We have 6 hydrogen ions on the product side, and we have 8 hydrogen ions on the reactant side. So let's subtract over that 6. The 6 is going to go away. 8 minus 6 is 2. We're going to have 2 hydrogens. We would be done, besides, rewriting it all out and making it nice and neat, if we were balancing in an acidic solution. But we are balancing in a basic solution. So let's go ahead and put this thing back together and then finish up with our hydroxide ions. Okay, so I've got 2 hydrogen ions plus 2 MnO4 minus plus 3 Cn minus arrow 3 Cn0. Okay, so I've got this all put together. Now remember, we're going to find our hydrogen ions. We've got 2 of them, and that's how many hydroxide ions we need to add to both sides. Hydrogen and OH, they combine to make water. So we have 2 waters here now. So we have 2 waters here, 1 water here. So let's reduce that down. Let's subtract. We will have 0 waters over here, and we will only have 1 water here. Okay, let's rewrite and get our final answer. That one was kind of a lot, but I really wanted to include that one because I feel like it's a really good, solid example. You come up against a lot of different challenges, but it's a very, very, very fair question. I know we had to write a whole lot when we were balancing in an acidic solution, a basic solution, but if you follow the steps every single time, you'll always get it right. I still have a few more lessons for redox reactions. Until next time, bye y'all.